Okay, last part of the alpha and beta decay lab. It's just the practice paper. So first off, this first table is a little bit confusing because you need to look at this table up here and talk about it in this table down here. So in this table up here, we have a parent isotope, the particle emitted, and the daughter isotope. So parent isotope in this case is radium-226, particle emitted is helium-4, and the daughter isotope is radon-222. When we're looking at these, you're going to look and think about the change from the parent isotope to the daughter isotope. What is the change in atomic number as we go from 88 to 86? Did it gain? Did it lose? How many did it gain or lose? Number of protons lost or gained. Here it's already got that filled in for you. Lost 2. Number of neutrons lost or gained. And this is, I will say, the trickiest part, because a number of people are going to look at this and they say, oh, it went from 226 to 222. It lost 4 neutrons. It did not lose 4 neutrons. It lost 4 total mass. Of that 4 total mass, I know that 2 of them were protons. So the amount of neutrons that it lost is 2. It lost 2 protons, 2 neutrons. That's why the change in mass number is 4. So one thing that we've been coming across a lot in this, or that I've been noticing a lot, is that people are sometimes mixing up mass and neutrons. Remember, mass is protons and neutrons together, not just the neutrons. So something to think about as you're doing this. Is this alpha or beta decay? This is alpha decay, as you can see. So as you go through and look at equation number 2, it tells you it lost 2 neutrons. As you go through and you look at equation number 3, it doesn't give you any information. You have to figure it out. Equation number 4, it tells you that mass change is 4. And then equation number 5, it tells you the change in atomic number is +1 because it goes from an atomic number of 6 to an atomic number of 7. And then this is beta decay. All right, so think about that, filling that out. What changes take place in the nucleus when an alpha particle is emitted, which means released? What element or subatomic particle is an alpha particle? So this particle right here, what is it? And it's going to ask the same thing about this particle right here. And it's asking element or subatomic particle because one of those particles is an element and one of those particles is a subatomic particle. The things we studied before that make up atoms, protons, neutrons, and electrons. So think about that. Basically just talked about that. When an alpha particle is lost from an atom, where on the periodic table would you look to find the product? So if I look at a periodic table here, and say I have something like iodine, which goes through alpha decay, am I going to move this way on the periodic table to the left to find the daughter isotope, or am I going to move to the right to find the daughter isotope? Fill in the missing parts for the nuclear reactions pictured at the right. So for part A, it's got a mass of 40 here, and it's got a question mark and a thing. So you're going to fill in what is the atomic number for this and what is the element. Here's a couple of things I'll tell you. On this, there are 2 things that you might not have seen before. This right here, that is the Greek letter beta. So it is the symbol for a beta particle. This right here is the Greek letter alpha. It is the symbol for an alpha particle. So when we are writing alpha particles, we can use this notation right here, or this notation right here, or you'll even sometimes see a 4 and a 2 and then an alpha symbol. Similarly, when you're doing a beta particle, you can use this notation here, you can use this notation here, although you will sometimes also see a 0, -1 beta symbol. It gets a little bit confusing, but it's just something to know. Beta particle can be represented like this or like this. Alpha particle can be represented like this or like this. So I'll just fill out the first one with you to kind of help you here. If I'm trying to figure this out, I remember that my atomic numbers on this side will add up. So remember, a beta particle has an atomic number of -1, so -1 plus 20, it's going to be 19. And what element is it? What element has a proton number of 19, atomic number of 19? That's potassium. So I'm going to switch back here. Yeah, so go through, do that like this. You can just fill it in like that. That would be great. Does the type of element change during radioactive decay? Why or why not? These, I think, are pretty simple questions. If astatine undergoes alpha decay, what type of atom will be produced? So you've got the alpha particle that comes off. What's going to be the daughter isotope? And then which isotopes are most likely to decay? This might seem like a trick question. I'm just asking a simple thing. An isotope is likely to decay if the element or atom of that isotope is what? What is a word you could use to describe it? That's about all I've got. Good luck with that.